In this lecture, we'll briefly take a look at what ACID properties are in a database management system. But before we can do that, let us first take a look at what transactions are. So a transaction is an executing program that performs a logical unit of database processing. A transaction includes one or more database access operations. So key type of operations, example, insertion, deletion, modification, retrieval operations. So after transaction, there could be a single or multiple of these operations. Achha. So let us look at what the A stands for in ACID properties. So A basically stands for atomicity. So this means a transaction is an atomic unit of processing. So even though previously I said that a transaction includes one or more database operations, by atomicity, a transaction is considered to be an atomic unit of processing. So basically, in other words, a single unit. It should either be performed in its entirety or not performed at all. So either একটা transaction completely perform হওয়া লাগবে বা perform হবেই না. So একটা example দেখি, suppose for example let's say you want to transfer some money to your friend via bKash. So suppose এই টাকা পাঠানোর ট্রানজ্যাকশনটা এদিকে দেওয়া আছে. Suppose this is you and this is your friend. So before the transaction you had, let's say, 500 taka and your friend had 200 taka, and you want to say, let's say, transfer 100 taka to your friend. So after the transaction you should have 400 taka and your friend should have 300 taka, right? So suppose the transaction is going to look something like this. So it's going to first read your balance, which is what's basically 500 taka. Then it's going to basically subtract 100 from 500. Basically your new balance, to get your new balance, it's going to do that, which is going to be 400. And then it's going to write that 400 in the database. So remember that I'm saying that even though there is a read operation here and a write operation here, this entire thing, I'm calling this entire thing a transaction. Okay, so by atomicity it means this entire transaction must take place or none of it will. So now imagine this part of your transaction gets executed. So you're left with 400 taka. However, for some reasons this part does not get executed. So what's going to happen instead is that your friend, instead of having 300 taka, he's going to be left with 200 taka, but you're going to be down 100 taka, even though that 100 taka is now basically lost. So this is basically not acceptable. Your transaction should either be performed in its entirety, basically has to be completely performed, or not performed at all. So you cannot have a transaction occurring halfway through. So basically that is what atomicity means. Okay, so now let's take a look at consistency preservation. So this is basically the C in ACID properties. So this states that a transaction should be consistency preserving, meaning that if it is completely executed from beginning to end without interference from other transaction, it should take the database from one consistent state to another. Basically, consistency has to do with constraints such as integrity constraints. So integrity constraints can be further broken down into key constraints, referential integrity constraints, etc. So we'll learn about this in possibly slide 5. So this type of constraints all have to be upheld when when a transaction takes place. So you cannot have any of these constraints violated when a specific transaction is completed. Basically, when these constraints are not violated, your database is in a valid state. Okay. So next up we have isolation. So in isolation, which is the I in ACID properties, a transaction should appear as though it is being executed in isolation from other transactions, even though many transactions are executing concurrently. That is, the execution of a transaction should not be interfered by any other transactions executing concurrently. So a transaction must behave as though it is being executed in isolation. So we know that in our database management system we can have multiple users accessing the database at the same time, suppose in the case of an airline reservation system. Okay, so now let us take a look at an example of this. So suppose you have two transactions here. So this is one transaction and this is a separate transaction, but let's say these two are occurring concurrently. In other words, these two are occurring at the same time. Okay, so suppose this transaction here first reads x, some value, and then it multiplies x by 100, and then it writes the value of x, and then it reads the value of y. And at the same time, while it's reading the value of y, this transaction starts and this transaction reads the value of x. So basically the value of x that has been written here is being read by this transaction. So at the same time, suppose this transaction subtracts 50 from y and this transaction reads y. However, this transaction is going to get the same value as this transaction got when it first read the value of y, because the value of y is being written here. So basically y minus 50, whatever the value is being written here. So when your second transaction reads the value of y here, it's going to get an incorrect value, right? As a result, the calculation that it's doing here, which involves y, is going to be incorrect as well. As a result, it's going to end up writing an incorrect value. So the isolation property basically states that even though you may have multiple transactions occurring at the same time, there should not be any interference. That is, the execution of a transaction should not be interfered with by any other transactions executing concurrently. So this should not happen. This sort of inaccuracies should not happen. Finally, we have durability, which is the last letter in ACID. So durability or permanency. So the changes applied to the database by a committed transaction must persist in the database. These changes must not be lost because of any failure. So suppose if you actually complete a transaction and commit it into a database, the values that you have written should be permanently saved. So even if there is a power failure, those values must not be lost. So that is basically what durability means. So in short, this was a look at ACID properties.